Today we're going to talk about forces, and we're first going to start discussing free body diagrams. So if this was a box sitting on the floor, the box would have a weight on it due to the pull from the earth, and the floor would push back up with what's called a normal force. And if this box is not falling, the upward force positive would equal to the negative force downward weight, and these forces would cancel each other or be in equilibrium. Similarly, if there were workers pushing, let's say, a big box, maybe with a refrigerator in it, and the workers pushed to the right with this applied force, and the box didn't move, the friction force to the left would be resisting that pushing force. Friction forces always occur in the opposite direction of the pushing force or the motion, and the workers could push harder and harder, and the friction force would go up and up and up and match the applied force until the box would begin to accelerate. All right, so we call this situation of equilibrium, where the forces are balanced, where the sum of the forces in either the y or the x direction is zero. The pluses cancel out the negatives, for instance. Okay, so it's helpful to think of what forces actually are. And we tend to think of in elementary school or middle school as forces are pushes and pulls, but a more evolved maybe understanding of forces is simply that they are interactions. So for instance, if I push on a wall, the wall pushes back on me. And this is Newton's third law. And that law continues to say that these forces are equal and opposite. So for instance, if an apple pulls on an orange, the orange pulls back on the apple with an equal and opposite force. Okay, so let's continue our discussion with vectors. Uh, Forces can be represented as vectors, and vectors are drawn as arrows with arrowheads, and they need two things. They need the magnitude or the size, in this case of a force, and the orientation, in this case the angle with respect to the negative y-axis would be an example. So this force could be thought of or could be representing a force in a guy wire. A guy wire is a cable that, for instance, attaches to an antenna or a telephone pole like this one. And if the wind pushes on the telephone pole in one direction, you'd expect the guy wire to pull back, let's say on the earth, in the other direction. And so this would be an example of the force, 5 newtons, and the angle, 30 newtons, at which it's applied from the negative y-axis. All right, thank you for listening.